Okay, here we are, Unit 4, Lesson 11. We'll start with problem 11.1. What we need to do is we need to find the area of these shaded regions. We're going to focus first on this first circle at the top. So here we go. We want to find the area of this shaded region. I recognize that I have two shapes. I have the circle, and then I have a square inscribed inside that circle. Okay, so what I need to do is I need to find the area of the circle and then subtract the area of the square, and that will give me the remaining shaded area. So just a reminder, I want to find the area of the circle, I want to subtract the area of the square, and that should be my total area that I'm looking for. So let's start with the area of the circle. I notice that this circle has a radius of 1 unit. There's my radius, and I know that the area for any circle is pi times the radius squared. Since I have a radius of 1, I can substitute that in. Pi times 1 squared. 1 squared is 1. Pi times 1, then I know that the area of my circle is just pi square units. Now I need to find the area of this square. The area of a square is a little bit easier to find. What we need to do is we just need to find the side length of the square and then square that side length. I notice that the side length here is the square root of 2. So I need to take that square root of 2 and square it. When I square the square root, they cancel, so the area of my square is 2 square units. Now to find my total area, remember at the top here, what I did is I took the area of the circle, which is pi, and I'm going to subtract from that the area of the square, which is 2, and then I can just use my calculator. And what I want to do is I want to take pi, the pi button on my calculator, and I want to subtract 2 from it, and I get an area of 1.41. We'll call it 1.42. 1.42 rounded to the nearest thousandth. So the area here is 1.14, no, 1. What did we say it was? 1.42. 1.42. That's the area of this shaded region. Now, when we scroll down here, finding the area of this shaded region is going to be a little bit tougher. What we need to recognize here is we need to recognize that we have, first of all, a hexagon. And in order to find the area of this hexagon, what I would suggest we do is we recognize that this hexagon is nothing more than 6 isosceles triangles. If we find the area of one of these triangles, then multiply it by 6, we have the area of our entire hexagon. The good news is the area of our circle has not changed. So the area of our circle is going to be pi square units. So now let's find the area of one of these triangles. So what I'm going to do is I am going to look at this triangle down here on the bottom, and I want to find the area of that red triangle. So the area of a triangle is equal to the length of the base of the triangle times the height of the triangle, all divided by 2. The base is down there on the bottom. The height, I notice, is this piece right here, which is the square root of 3 over 2. So the area of my triangle is going to be whatever my base is times the height, which is square root of 3 over 2, and we're going to divide that all then by 2. So what we need to do is we need to find the length of this base, BC. What I'm going to do is I'm going to take this triangle and I'm going to deconstruct this triangle into a right triangle. I know this altitude is this square root of 3 over 2. I know this is a right triangle. what I need to do is I need to remember, how did I find this vertex, this angle at the top here? So I know the hypotenuse, that radius is a 1. I need to find and figure out what is this central angle on the inside. Well, remember that all of these central angles are the same, and since they're all the same, all the way around it would be 360, but I have 6 of those. So it's 360 divided by 6, which gives me a 60-degree angle here for this central angle. But I only have half of that central angle here. So this angle must be 30 degrees. Now, I can use trigonometry. I can find this x value. Okay, because I know that the sine of that 30-degree angle is going to be the length of the side opposite, which is x, divided by the hypotenuse, which is 1. And remember, to solve this equation, I have a variable involved in a fraction. I need to multiply both sides by the denominator of that fraction to get rid of that. So I know my x value, 1 times the sine of 30, is going to be just sine of 30. So that is the length of this smaller size. When we go back over to our triangle here, we need to realize that we have not just one of those, but we have 2 of those. So the length of this entire base is going to be whatever 2 times the sine of 30 is. Okay, and I can use my calculator for that. Take 2 times the sine of 30. So I'll come in here. 2 times the sine of 30. And I get a value of 1. I get a value of 1. So now I know the length of my base is 1. Now I can multiply this entire thing out to find the area of this triangle. This is the area, remember, of the triangle. So 1 times the square root of 3 over 2 is just square root. But then I need to divide that by 2. Remember how to divide a fraction by a whole number? We do change to multiplication and then flip the 2. Becomes 1/2. Remember, multiply by the reciprocal. When we multiply fractions, we multiply straight across. So square root of 3 times 1 is square root of 3. 2 times 2 is 4. So the area of my triangle here is square root of 3 over 4. Now to find my total area. Remember, it's the area of the circle, which is pi. And I'm going to subtract from that the area of my entire polygon. Well, this triangle is square root of 3 over 4, but remember I have 6 of those. So I'm going to take this square root of 3 over 4, I'm going to multiply it by 6, and I get 6 square root of 3 over 4. Now I can simplify this fraction a little bit. My area is going to be pi minus 6 square roots of 3 over 4 will simplify to 3 square roots of 3 all over 2. Notice I just canceled the common factor of 2 from the top and bottom, turned that 6 into a 3, and turned that 4 into a 2. So here is the exact value for the area of my shaded region. If we're going to approximate it, we can just type this into our calculator. So I want to do pi minus 3 square root 3 divided by 2. So I go into my calculator, I do pi minus 3 square root 3 all over 2. Enter, and I get 0.544 units square.